Consider this given problem statement. Let P and Q be integers, and here alpha and beta are the roots of the equation that is given as this, that is x square minus x minus 1 that is equal to 0, and here it is mentioned that alpha is not equal to beta. That means these two roots are distinct, and here n can take the value that is 0, 1, 2, 3, and it goes continuously, right? So here it is defined that a subscript of n is given as p times alpha to the power n plus q times beta to the power n, where n belongs to this set of non-negative integers, right? And here we have given a fact, we are given a fact here, that if a and b are rational numbers and a plus b times square root of 5 is equal to 0, in that case a and b has to be 0. So that is the given fact. So if a subscript of 4, that is 28, so in that case we need to compute the value of p plus 2 times q. So that is the requirement of the problem statement. Now let us proceed towards the solution. Now if you observe, this is the given equation to us, right? Now what I'll do here, I'll substitute r for a moment, right? So this one can be written as r square minus r minus 1 that is equal to 0. Now in this case what I'll do is I will be multiplying r to the power n minus 2, right? So why I'm doing this? Once I'll proceed towards the upcoming steps, you'll get the clarity that why exactly I'm multiplying this r to the power n minus 2. So in this equation, I will be multiplying r to the power n minus 2 on both the sides. So here I'll take this one, and here r to the power n minus 2 over here, and on this entire expression I will be multiplying r to the power n minus 2. Now on performing this operation, I'll be getting here r to the power n minus r to the power n minus 1, and here r to the power n minus 2, this is equal to 0, right? And we are considering that this one is valid, this one is valid for r belonging to this interval, that is not interval, the set which contains the roots alpha and beta, and of course these two are not equal, right? These are distinct. Now I will substitute here in this equation. I'll be substituting alpha once, and then I'll substitute beta over here, right? So in the very next step, I'll replicate this one and substitute the required values. So in this one, I will be substituting alpha first. So in this one, I'll replicate this, and here I will be writing alpha here, alpha to the power n, alpha to the power n minus 1, and alpha to the power n minus 2, right? And on the next one, in the next one as well, so I'll take this one, and here I'll be replacing this one with beta. So this will be beta to the power n, then beta to the power n minus 1, and then beta to the power n minus 2. Now in this expression you can observe that with alpha p is multiplied and with beta power n q is multiplied. So in this given equation, in this one which I have selected, this is the selection here. So in this one I will be multiplying p on both the sides, right? So I'll take this one, I'll replicate this and multiply p on both the sides. So this one within parenthesis, multiply p over here, and p multiplied with 0 will be 0 itself, right? Similarly, for this one, I will be multiplying q on both the sides. So this is q times the given equation with beta, and this one 0 multiplied with q is 0 itself. Now, so let us consider that this one as, this one I will consider as equation 1, and this one I will consider this one as equation 2. Now adding this equation 1 and 2, so on adding this, on adding this 2, I will be getting, so I'll remove this part, this is not required. So this implies clearly that first of all you can see p times alpha power n and q times beta power n. So this is something which will definitely arrive here in the expression, right, on adding this one. So this will be the first term, right? and then negative, this will be p times this exact quantity with power n minus 1, p times alpha to the power n minus 1 and q times beta to the power n minus 1, right? And then here again minus, here it will be with n minus 2. So the same expression here with n minus 2 in the power of alpha and n minus 2 in the power of beta. So this is equal to 0, and in the problem statement it is clearly mentioned. So I hope you got the clarity that why did I generalize this factor here, right? Now this is something that is given as a subscript of n. So this one I will be writing here as a subscript of n. So similarly the next one can be written as a subscript of n minus 1, followed by this I can write here minus a subscript of n minus 2, n minus 2, that is equal to 0, and I can definitely mention the reason because it is clearly given in the problem statement, and hence we can make such kind of replacement. So finally we arrived at this place, right? Now it is given in the problem statement, it is given in the problem statement that for n equal to, for n considering this non-negative integers, right, for these values it's already given that this one, that is a subscript of n, is equal to p times alpha power n plus q times beta power n, right? And this is something that we have concluded till now, right? So this equation is the concluded equation. Now I will be following the procedure, this particular equation I will take this further and try to solve it and get this value, that is a subscript of 4, and using that I'll try to compute this value of p and q, that is p plus 2 times q, right? So let us go ahead with this. So this can be written as a subscript of n, a subscript of n can be written as a subscript of n minus 1 plus a subscript of n minus 2, right? A subscript of n minus 2. Now this one can be written as a subscript of 4. Why am I writing 4? Because in the problem statement it is given that a subscript of 4 is equal to 28, right? So let me also write that this is also given to us. So a subscript of 4 can be written as a subscript of 3 plus, so this will be a subscript of 3 plus a subscript of 2, right? Now again this a3, that is a subscript of 3, can be expanded further as, this can be written as a subscript of 2 plus a subscript of 1. So this one can be written as a subscript of 2 plus a subscript of 1, and a subscript of 2 can be written as, a subscript of 2 can be written as a subscript of 1 plus a subscript of 0, right? Now further again whatever the replacement for this a subscript of 2 we have made, I'll take this one and replace this a subscript of 2, I'll replace this a subscript of 2. Now on resolving this further, a subscript of 4 can be written as 3 times a subscript of 1 plus 2 times a subscript of 0, right? And finally we can say that a subscript of 4 will be equal to this 3 times a subscript of 1. So instead of this one, I will be writing this particular figure with the power of 1. So here the power is 1. So p times alpha power 1, and here q times beta power 1. And for this a subscript of 0, when I substitute here, so p times alpha to the power 0 plus q times beta to the power 0. So now it is given to us, this fact is given to us, we'll be using this fact actually that is given here, right? So this fact, I'll be using this fact, right? So I'll take this one and I will be using this fact. So yes, that is if a and b are rational numbers and we are having this form, that is a plus b times square root of 5, that is equal to 0. So in that case a and b has to be 0. So that is the requirement here. Now this is the equation that was given to us. So I'll just write the given equation now. So let me just eliminate this part, and this is the equation that was given to us, x square minus x plus minus 1, that was equal to 0. This is the given equation, right? Now definitely we can say that my r if I substitute, let's say r here instead of x, let's say, so r square minus r minus 1 equal to 0. So from this we can say that r belongs to this roots, that is alpha comma beta. And what will be the value of this alpha and beta? So from this we can clearly say that r will belong to this golden ratio, right? This is a very famous quadratic equation, by the way, 1 minus square root of 5 over 2, and here the conjugate of this, that is 1 plus 1 plus square root of 5 over 2. So that is the roots, that is alpha and beta, right? Now I will be proceeding ahead with these values. So now it is given, now we have already computed this fact that this a to the a subscript 4. So a subscript 4 is something that we are already having. Now I will be proceeding ahead with this. Okay, so here now I will proceed with this upcoming steps, that is a subscript of 4. Now proceeding with this, a subscript of 4 is nothing but 28, and here I will make the appropriate substitutions. So from this we can clearly observe that this can be written as 2 times p plus q in simple terms, right? And this alpha can be replaced with this, considering that alpha is this particular value, that is 1 minus square root of 5 over 2, and 1 plus square root of 5 over 2, that is beta. So instead of beta I will make this particular replacement. Now on resolving and rearranging these terms, this can be written as 28, that is equal to, so this one if you resolve, this will be 3p over 2 plus 3q, 3 times q over 2 here, plus 2 times p plus 2 times q, plus on the other side this would be 3p over 2 minus 3 times q over 2, right? So here with the negative sign, right? And this square root of 5 will be common over here. This will be the common factor here, right? So now I have tried to write this expression in this given form, that is a plus b times square root of 5. So you can observe this can be compared with a, and this one can be compared with b. Now both of this can be compared to 0, right? So finally we can say that this 28, if I can replicate in the next step, so in the next step I will be writing this one as 28 plus 0 times square root of 5, 0, and here let me give the symbol, 0 times square root of 5 is equal to this. Now in the next step we can write in the next step, so at this part, so this particular implies that is 0 times square root of 5, 0 times square root of 5 is comparable with this particular factor, right? So from this we can clearly observe, on resolving this we will be getting p is equal to q, right? That is one component. And if I check for the other component, that is with 28, right? So this time with 28. Now let me write here, that is 28 is equal to this particular quantity, correct? Now from this, on resolving this one, we will be getting, that is 28 times, if you resolve this part, this will be 7 times of p, and from this we can say that p will be equal to 4, and p is equal to q, we got this. So if p is equal to q, that means the value of p and q both are 4, right? So finally the expression that is being demanded here, that is p plus 2 times q, that is equal to what? So finally we can say that therefore p plus 2 times q will be, here p is 4 plus 2 times 4, and this will be equal to 12. 8 plus 4, that is 12. So 12 is the answer for this particular problem statement, right? So you can observe that we have taken the equation, and then we have checked for the validity, and finally we, after the manipulation, after substitution of this alpha and beta, we arrived at this particular equation, right? For on solving this equation further, I got the relation of this a subscript of 4 with a subscript 1 and a subscript of 0. On using the properties that were given on the problem statement, after using all of those, I arrived at this final equation, that is 28 plus 0 times square root of 5 is equal to this particular quantity. And on making appropriate comparisons, I got that is p is equal to q is one important equation and p is equal to 4 is one of the important value. On substitution of all of this on the demanded expression, I got the answer as 12, and hence this is the solution and the answer.